This example. We have something, the function is f of x equals 3 over x. Okay, and what we want to find, we have two assignments here. We need to find first the derivative in general terms, f prime of a. So we are not giving a specific value. And part B, we want to find the equation of the tangent at x equals 3. So notice what we are required to do in part A. In part A, we need to find the derivative at the point, but we are not given the specific of the point. So as we continue, as I said, in this case, we're going to find the derivative at the generic point A, unspecified value. Unlike the example before when we had x equals a equals 5 or a equals 1. So the first solution, going back to the definition f of a, and I chose to go with the modified definition. So we have the limit as h approaches 0 of f of a plus h minus f of a over h. So we're going to start manipulating this thing. First of all, let's replace the specific function. So the limit as h approaches 0. F of a plus h will be 3 divided by, instead of x is replaced by a plus h. And f of a, of course, is 3 over a. And this is the numerator. The denominator is still h. So again, I'll multiply, instead of dividing by h, I'll multiply by the reciprocal, 1 over h, to save me a long fraction bar, like so. Now I'm looking at the numerator, and I see that I have a difference of 2 fractions. And if we subtract, normally we need to come up with a common denominator, right? And the common denominator will be a times a plus h. So, and here's another reason why I changed it to 1 over h, because I knew that I have a fraction bar in the numerator. So here we have a plus h times a, like so, and then 3 is multiplied by a, so we have 3a here, and this 3 is multiplied by 3a by h plus a plus h. So I'll go ahead and save time by multiplying out, so it will be negative 3a and then negative 3h, like so. And you can see what happened. 3a minus 3a cancel out. My 5-minute warning. And what's left is negative 3h divided by a plus h times a, like so. H and h are being reduced, so let's move to the next page. And at this point, what's left, take my hand off so you can see actually. So we have the limit as h approaches 0. What's left is the negative 3 on top. And at the bottom we have a plus h times a. Okay, and now I can do the formalities of the limit laws, but we've done this enough. So what we can do, we can see that if I just substitute, I have a squared. So I have no holes here. I don't have a vertical asymptote. I'm not violating any continuity issues. The function, is defined for h equals 0. So just by simple substitution here, I'm going to end up having negative 3 over a squared. And this will be the answer to the first part. Okay? I don't know if you realize what we just accomplished here. We find an expression for the derivative or the slope of a tangent to this particular function, 3 over x, at any generic point x equal a. We didn't specify the value of a. Go ahead with your question, please. The first step of the problem. Please lead me the third one. Are you talking about this line right there? Okay. Common denominator, right? The common denominator is a plus h times a. So I need to multiply this 3 by a and this negative 3, because I have negative, by a plus h. So you have negative 3a and negative 3h. Okay? And this leads to the cancellation of 3a on top and leave us with only negative 3h in the numerator. And of course, h divided by h is 1. So we can reduce. And what's left at the end of the day is negative 3 divided by the quantity a plus h times a. Go ahead, JT.
On the practice test, they have a graph where it has, it's like angled, and it's going from point to point to point.
Let me hold on to your question because of a time constraint. I want to finish this particular example and I'll address your question after we finish this example. Okay? Because otherwise I won't be able to complete this particular example. Okay, the next part is find the equation of the tangent. Okay. I like to make a comment before I go to the next part. Okay, and this is an important enough comment that I'm going to write it in color, because this is really going to take us to the next topic next week, and it tells you that the derivative function. So here's a very important comment. Okay, so let's write it here. If you can see farther down the road, so we can say, although f prime of a is the derivative at a point okay, in this case the point is a comma f of a. All right. A can be replaced by any value. And that's what I said before. We found it for a generic value a. So if a can be replaced by any value, then, and I'll put a in quotation mark. So a in quotation mark might as well be replaced by x, because a is in fact a variable. That's what we mean by replacing by any value. So okay, so we can say that instead of a, we're going to replace it, f prime of x will be negative 3 over x squared for a generic value of x. And where f prime of x is the derivative function. So we have derivative at a point, but also we have derivative function. And let's quickly now do the second part, part B. Okay, what happened at x equals 3? At x equals 3, f of 3 equals 3 over 3, or it's equals 1, right? And now the derivative f prime of 3 equals negative 3 over 3 squared, and we end up having what? Negative 1/3. So we know that the slope, therefore, m tangent equals negative 1/3. So we have the point 3, 1, and we have the slope, and we have the point 3, 1, and the slope, which is negative 1 over 3. Therefore, y equals 1 plus or minus 1 over 3x minus 3, okay? Or we have 1 minus 1 over 3rd x plus 1, so y equals negative 1/3 x plus 2. And this is the equation of the tangent. I wish I have time to show it on the graph program, but hopefully you pretty much know how to use the graph program, and I'm 2 minutes past my time, so I might as well stop here. All right.